This is section 8.6. In this section, we're going to be graphing logarithmic functions. Your homework for this section is 97 through 114. So let's suppose I have f of x is equal to log base 2 of x. This is going to be a generic log function. So what I'm going to do is I'm going to take the x value and I'm going to plug it in. So I have y is equal to log base 2 of 1/16. Now remember, the answer to a log problem is an exponent. What I'm asking you is 2 raised to what power gives you 1/16. Since there is a fraction involved, that will be a negative exponent. So if I have a 2 and I raise it to a power, what will give me 16? So if I take 2 times 2, that will give me 4, 8, 16. So 2 to the 4th power is 16, so if I have 2 to the negative 4 power, that will give me 1/16. So if I plug in 1/16, then my exponent will give me -4. -4. We're going to do the same thing with 1/8. So what I'm trying to find is what exponent do I raise 2 to get 1/8? Well, 2 to the 3rd power gives me 8, so in order to get 1/8, I got to have -3. Keep going. I'm going to plug in x is equal to 1/4, so log base 2 of 1/4. 2 to the 2nd power will give me 4, so -2 because it's a fraction. Let's do 1/2. So if I have log base 2 of 1/2, then I'm asking what's the exponent? Well, 2 to the 1st power will give me 2, and so if I want 1/2, which is 1/2, I need a negative exponent. So now I'm going to plug in x equals 1. So log base 2 of 1. Now be careful when you do this, because what I'm asking is what's the power that I raise 2 to get 1. And remember, anything to the 0 power gives you 1. So if I plug in 0 to this function, I will get a y value. Sorry, if I plug in 1, I will get a y value of 0. I said that wrong. Okay. And continuing on, log base 2 of 2. 2 to the 1st power will give me 2. Log base 2 of 4. 2 to the 2nd power will give me 4. And log base 2 of 8. 2 to the 3rd power will give me 8. So I'm going to plot these points. So 1/16. Well, you guys know that 1/16 is a very, 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 very small fraction. So you're going to want to get as close to the y-axis as possible, but not actually cross it or actually be on the line. So x is equal to 1/8, y is equal to -3. So 1/8 is a slightly bigger fraction, but it's still pretty small. X is 1/4, y is -2. Again, small fraction, but it's slightly bigger. X is 1/2, y is -1. It's going to be halfway in between. X is 1, y is 0. This is the point you're going to keep your eye on. 1, 0, 2, 1, and 4, 2, and 8, 3. Okay, so if I connect those dots, I have this graph. I missed the point there. There you go. This one again has an asymptote, but notice it is not a horizontal asymptote. We are getting closer to a vertical line, and the equation for vertical lines is x equals some number. In this particular case, the x value at this asymptote, the x value there is 0, so my vertical asymptote will be x equals 0. I told you to pay attention to this point because that's the point you're going to be shifting when you graph the log functions. So we write log functions in general. F of x is equal to k plus log base b of x minus h. Notice we still have the h and k. The h is going to shift us left or right, where the k is going to shift us up or down. The only thing different is occasionally we put the k in front and sometimes we put the k on the right hand side. So it doesn't really matter where you put the k, but it's still going to go up or down. The point 1, 0, that's the point that you're going to be shifting, and don't forget about the vertical asymptote. So let's suppose I want to graph log base 3 of x minus 1. Again, it doesn't matter what this number is. All of the logarithmic graphs are going to look the same. They're all going to go through this point unless we shift them. So if I have x minus 1 that's in parentheses, that's going to be inside the log. Inside the log means we move left or right. And if this is negative, we're going to go in the positive direction. So we're going to move this point 1 unit to the right. Our vertical asymptote, we also have to move that 1 unit to the right. It started out at 0, so we're going to move it 1 unit to the right. Okay. And remember, when you draw your graph, it has to go through that point that we shifted. The line is going to get closer and closer to our vertical asymptote, but it's not going to cross it. If we move 1 unit to the right, we're now at x equals 1. So our vertical asymptote is x equals 1. Two plus log base 4 of x. Again, it doesn't matter what the base is. The graph is going to look the same. I have 2, and it is outside, and it is a positive 2. Outside and positive is going to shift us up. Normally, the point is 1, 0, but if I move that up 2 units, that's the point that I need, and I don't need this one anymore. Okay. If I'm just going up or down, my vertical asymptote doesn't move, so my vertical asymptote is still going to be at 0. And then my graph is going to look like that. X equals 0, vertical asymptote. This one has 2 shifts. I have the -1 outside, which is going to move it down 1. And I have x plus 2 on the inside. Positive, remember, when it's inside, it goes opposite. So my point originally is here, but I have to go down 1. Okay, so down 1. This is a temporary point. We're going to erase it. But I also have to go left 2. So don't forget about the 0. So here's 1 unit, and here is a 2nd unit. So this point right here, which is where we started, went down 1 and left 2. So let me erase those temporary points that we don't need anymore. And there we go. All right, we shifted left 2, which means the horizontal asymptote also has to shift left 2. Normally it starts at 0, so if I go 2 to the left, 1, 2 to the left, here's going to be, I think I said horizontal, but I meant vertical asymptote. And my graph has to go through this point. Now take a look. My vertical asymptote is 2 to the left, so it started at 0. 2 to the left will be x equals negative 2. Natural log of x. Remember, natural log is the same as log base e. And again, it doesn't matter what that number is. The natural log or the log function always goes through this point right here, 1, 0, unless we shift it. And the vertical asymptote is going to be at x equals 0, again, unless we shift it left or right. So natural log is going to look the same as log of x, or log base 2 of x, or log base 10 of x. This question is asking something slightly different. It's asking to describe the transformation. I don't actually want you to graph it. So I have natural log of x minus 3 plus 5. The plus 5 is outside. Outside goes up or down. Since it's positive, it's going to go up 5 units. And I have x minus 3 on the inside. Remember, on the inside, it goes opposite of what you would expect. So instead of going in the negative direction, we're going to go in the positive direction, which is to the right, 3 units. Again, describe the transformation. So this one, I have a negative 12 on the outside, so I go down 12. I have a positive 6 on the inside. I need to go in the negative direction, which is left. 6. And that is example 7. So if you have any questions, be sure to let me know in class.